Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Sofian bin Sulaiman. I am from University Malaysia Terengganu. I'm going to present a paper with the title Erosion and Sedimentation at Headwater Stream, a case study for Pergau water intake. Now these are my presentation outline. Now we need to understand the river classification and its relationship with the fluvial processes. Now most of the past researchers, they have classified the river system into two broad major themes, which are the biological and physical river system. And in a summary, I would say that the rivers near the Pergau Lake can be considered as a mountain river system. So when we are talking about the mountain river system, these river systems are very sensitive because it contains high potential energy, and because of the high potential energy, it will dissipate the energy by having a sediment transport process. But the human activities or anthropogenic stresses might induce or might alter the fresh water river system, whereby we can see there are a lot of siltation issues and there are a lot of sediment stuff flows. One of the main problem that we have at the headwater stream or at the mountain river system is the reservoir sedimentation because of the siltation, and because of that government need to spend millions of ringgit to dredge or to desil the sediment. And another problem that we can see is the riverbank erosion and scour at Bridge Pier due to the hungry water phenomena. Now I want to share a video on the reservoir sedimentation.
This is a video of us getting stuck. Dr. Sofian is stuck, Nadia and I are stuck.
Okay, so these are one of the major issues that we have at the mountain areas, whereby because of the construction of dam, the siltation at the plunge area or at the river mouth before entering the reservoir lake is very crucial. So because of that, we come up with this objective of research. We want to determine and assess the soil loss at the catchment area. We want to determine the sediment load at the ridge scale, and we want to know the extent of the riverbank stability as well as the toe erosion near the intake facility. Okay, so these are the approaches that we have come up with to answer the research objective. So of course the study area, we go to all TMB water intake near the Pergau Lake. So they have about 7 water intake that finally drain through a channel to the Pergau Dam. So first we need to delineate the catchment for the TMB water intake near Pergau Lake. So there are so these are the catchment area. We have Terang catchment, Suda catchment, Renyok 1, 2 and 3, and Sungai Long 1 and Sungai Long 2 catchment. So the morphometric properties of this catchment or the water catchment is, if you can see from this table, the Terang water intake consists of the highest water catchment area compared to the others, and most of the elevation, I would say the majority of them are in excess of 1000 meter from mean sea level, which signify the location of this water intake at the mountain area. Alright, so in order for us to do computation on soil loss, first we need to know the rainfall erosivity. So by having the rainfall data, we should be able to calculate the yearly rainfall and then calculate the rainfall erosivity using this formula. but at the end of the day, I'm choosing the TAE 2011 formula because this formula was developed based on Malaysian climate condition. And from this rainfall erosivity, I convert them into the raster map. And then after that, we need to obtain soil erodibility. So I would say for truncation, the soil erodibility is 0.047, and then I convert them into the raster map. And then from DGT elevation model, we should be able to have or to illustrate this slope steepness. And then from those formula, we need to have another parameters on the cropping and management practices factor. So I'm adopting the values given by Abidin et al. 1999. And from your right hand side, you can see the annual soil loss for terang water intake or truncation in ton per hectare per year. So you can see that the majority of them are having the values of less than 2, which signify the soil erosion class of very low. So you can see the classification of very low, which is less than 10. Now at the reach scale, when we go to the river system, we do this river team data measurement, and then you can find that there are 4 areas that showing sediment load during the sampling time or during the clear day: the Suda intake, Renyok 1 both upstream and downstream, and Sungai Long intake at the upstream. But you can see that Renyok 1 and Renyok Suda intake consists, I would say, the highest amongst them, 30 times 10 negative 3 and 2.4 times 10 negative 3 kilogram per second. Now with this information, we run the simulation to find the stability of river bank at both Suda and Renyok 1 water intake, because they have water intake over there. So we want to see what is the stability of river bank upstream and downstream from the water intake. Now these are the figures. So you can see that the red color is the possible failure plane if we have erosion. So the upper part is the river bank, the failure plane for river bank, and the bottom part is the toe. So when we are talking about the river bank, we are talking about the bank material because of the bank angle and friction slope. But when we are talking about the toe erosion, we are talking about the erosion caused by the hydraulic force of water. Now from this result, we can see that Renyok 1 having the maximum lateral retreat highest compared to the other water intake of 150 centimeter. But both river bank, in terms of factor of safety, there are greater than 1. So I would say if the FOS is greater than 1, so the river bank is safe. But in terms of toe erosion, the value of 150 centimeter is in accordance to what we observe during sediment load measurement. So for conclusion, I want to emphasize conclusion number 4. Renyok 1, Suda, and Long 1 intake recorded transport rate during the clear day, and then the transport rate at Renyok 1 can be considered higher for a headwater stream, and the toe erosion at Renyok 1 was susceptible to erosion, which might explain why the high amount of transport rate were recorded. So I think that's all for my presentation. Thank you very much.